Welcome to Curious Chemistry channel. Today we will be seeing about reactions of alkynes. Some of the reactions of alkynes we have already seen in part 1. Now we will be seeing the remaining reactions of alkynes. Now let us go into the reactions. In the last class we have seen addition of halogens. So halogens add to alkynes to form dihalides and tetrahalides. How about addition of halogen acids? So halogen acids add to alkynes to form a halide derivative. Say for example, acetylene adds to HBr to form CH2CHBr, vinyl bromide, which adds to one more molecule of HBr to form 1,1-dibromoethane. Here what we have to see is the Markovnikov rule. What is this rule? Markovnikov rule. It says that the negative part of an addendum goes to the carbon atom with least number of hydrogen atoms. I repeat, the negative part of an addendum goes to a carbon atom with least number of hydrogen atoms. So here the addition of halogen acids follows Markovnikov's rule. Let me explain it clearly. HBr will have H plus and Br minus. So Br minus is our negative part. This Br minus will go to a carbon atom with least number of hydrogen atom. This is what your Markovnikov rule says. So let us see with the examples now. Acetylene, the triple bond, one bond will shift to a carbon and hydrogen will add to one carbon and bromine will add to another carbon to form a vinyl bromide, CH2 double bond CHBr. Now the second molecule of HBr adds to it. Now comes the Markovnikov rule, where in the carbon 1 we have one hydrogen and one Br. In the other carbon we have two hydrogen. So applying a Markovnikov rule, a H plus will go to a carbon with CH2 and Br minus will go to the carbon with CHBr. That is, the negative part Br minus will go to the carbon atom with only one hydrogen. So you get 1,1-dibromoethane. So if it is the case with the symmetrical alkene, what about unsymmetrical alkenes? The unsymmetrical alkenes follows Markovnikov rule even from the first step. That is, CH3C triple bond CH, that is propyne, adds to HBr. Now H plus Br minus. Here carbon 1 has one hydrogen, carbon 2 has no hydrogen and the carbon 3 has 3 hydrogen. So the Br minus will go to a carbon atom with least number of hydrogen atom, that is to carbon 2. So you get 2-bromopropene. To this, again one more molecule of HBr will add. Again it goes into H plus and Br minus. Carbon 2 has no hydrogen, so Br will go to the second carbon to form 2,2-dibromopropane. So halogen acids follows the Markovnikov rule while adding into acetylene. Now how about the addition of halogen acids in the presence of peroxide? What is the influence of peroxide? Peroxide will make anti-Markovnikov rule to apply. That is, halogen acids will add to an alkyne in the presence of peroxide to form a halo derivative following anti-Markovnikov rule, meaning that the negative part of the halogen go into the carbon atom with more number of hydrogen atom. So to explain it clearly, if we talk about acetylene, it adds to Br and hydrogen peroxide to form a vinyl bromide. Now your anti-Markovnikov rule applies here. So Br minus, which is negative, will go into a carbon which is having more number of hydrogen atom. So CH2 will get the Br and CHBr will get the H. So the resulting product will be 1,2-dibromoethane. Next is addition of hypohalous acids. So two molecules of hypohalous acids add to alkyne resulting in a haloketones, dihaloketones based on Markovnikov rule. I have already explained what is Markovnikov rule. So applying the same rule here we have CH3C triple bond CH propyne adds to hypobromous acid to form 1,1-dibromoacetone. Similarly, ethyne, that is acetylene, adds to hypobromous acid to form 1,1-dibromoacetaldehyde. Addition of hydrogen cyanide. Acetylene adds to hydrogen cyanide in the presence of barium cyanide as a catalyst to yield vinyl cyanide or acrylonitrile. So CH triple bond CH plus HCl will give you CH2CHCN, that is acrylonitrile or vinyl cyanide. Now let us see about oxidation reactions. Alkynes on oxidation with alkaline potassium permanganate gives carboxylic acid. Actually, this potassium permanganate cleave the molecule at the triple bond to form carboxylic acids and carbon dioxide. Say for example, propyne on oxidation with alkaline KMnO4 forms acetic acid. Acetylene will give oxalic acid. The same acetylene in the presence of chromic acid will also give acetic acid as a product. Next reaction is ozonolysis, that is addition of ozone to alkyne. So acetylene on ozonation gives a ozonide which decomposes to give glyoxal. So CH triple bond CH with ozone gives a ozonide which on treatment with water gives glyoxal. But higher alkynes like propynes and butynes react with ozone to give ozonides which on decomposition with water yield a diketone. This diketone is oxidized to acids by hydrogen peroxide produced in the reaction. So finally we get carboxylic acids as the end product from ozonolysis of higher alkynes. So next is hydroboration reaction, that is addition of diborane to a molecule of alkyne. So acetylene reacts with the diborane to give vinyl borane. This vinyl borane on treatment with an acid forms ethylene. So higher alkynes react with diborane to form similarly vinyl boranes which on treatment with acidic hydrogen peroxide forms carbonyl compounds as a product. The last reaction is polymerization. So alkynes on polymerization gives aromatic hydrocarbons. Say for example, acetylene when passed through a red hot tube polymerize to form benzene. Similarly, propyne when passed into a red hot tube forms 1,3,5-trimethyl benzene. We can say that this reaction provides a method for passing from aliphatic to aromatic compounds. So alkynes can be easily converted into aromatic compounds by polymerization reaction. So to sum up, I have given here a flowchart containing all the reactions of alkynes whatever we have studied so far. So this flowchart gives a reagents and the products separately for your ready reference. So with this we end the reactions of alkynes, the part 2. So for reactions of alkynes part 1, say Curious Chemistry channel. Next video will be on Dienes. Thank you.